Hello everyone, in this video tutorial we're going to be going over expressions and primitive values in OCAML. If you don't know what that means, we're going to basically get started with the types of things you could do in OCAML. So previously I had, in the previous tutorial, make sure everything worked, I had print string hello world. Basically what print string does, and I'll type it again, and let me actually zoom in a little bit for you guys. Alright, that's too much. Oh boy, let me see. Print string hello world. We're going to analyze this right here. So I run this. So again, to run our programs, and I'll go over this in just a minute, OCAML c-o video.videoml. Sorry. Gonna have function. Oh, there we are. Alright, and OCAML run hello world. So let's go over everything that just happened. So I have a file called video.ml, and I call this function OCAML c-o video.ml. So what's going on in this? Well, we're telling the compiler to take our code and make it readable for the machine or the computer that we're working on. So that's the role of a compiler. It takes this guy and turns it into a bunch of ones and zeros, as illustrated by my great art right here. You have video.ml, OCAML c, and then it creates a bunch of what are called object files. Object files are readable by the computer, and we are able to load those files into the computer's memory, or we're able to take these object files and have them get placed under the computer's vision to run, essentially, if that's an analogy, through OCAML run. So video.ml is our file, right? And that changes whatever you name your .ml file. And then this video argument right here is the name of our object file. So I could easily change this and say OCAML c-o, which means generate the object file, -o. Don't really worry what that means. We'll get into different variations in future videos. -o, we could call it like mic video.ml. And now it creates a mic object file. So really, we're just specifying with that like command before the .ml what our object file is going to be named. Now I can't say OCAML c-o video mic.ml because mic doesn't exist. And so once we have that, I could just say OCAML run mic, and we'll get hello world again. So we're taking this mic object file, and we are running it in the computer. The computer, OCAML run, gives the object file to the computer, and the computer says, okay, I know what to do with this. I print hello world. And if we go to mic, yeah, it's in binary, so this IDE has no idea what it is, but it's the equivalent of us saying print string hello world. So what exactly is print string? Well, we have kind of an idea that print outputs to this terminal or command prompt right here. We know that we have to surround something in quotation marks, and we know we have these double semicolons. So let's break this down. Print string outputs the following string to your terminal or command prompt, like so. The next argument is a string. Now we're going to go over this right now. There's many types of what are called primitives in OCAML. So one of them is a string. It's just a series of text. And a string is characterized by quotation marks. So if I remove the quotation marks, the compiler is not going to know what to do, because it expects a string, but yeah, no, oh, sorry, that was yeah. Well, that's a different error. Let's go back to our video.ml. Yeah, it expects a string. It doesn't really have a string. Too many arguments, and maybe thinks that these are individually strings. No, it has no idea what's going on. So all strings and all series of text is surrounded in quotation marks. And then we end our command with these double semicolons, and that's just to say, okay, that's the end of our expression, end of our line there. We don't want to do anything else with this line, because in OCAML, I mean, say you had like, instead of hello world, you had a page of text. You can't fit it all into one line, so maybe go into extra lines there. So it's just saying that's the end of our command. Now you may execute that one line. So we can even change this up. We could say, hey Mike, and that'll run just fine. And what happened? Oh boy. Okay, if you get stuck like that, this thing's not showing up, just do Control-C, and that'll take care of that. OCAML C video.ml, and we're gonna run Mike. Okay, perfect. And oh wait, Mike is our old object file. We just generated a new object file called video. So let's say video, and we get Hey Mike. Cool. All right. So that's a string. Now we could take care of other things like numbers. So say we want to say print int, which is printing an integer. An integer is a non-decimal number. If you remember from math class, print int 5. We run this again, and we get the number 5 to our terminal. What's even cooler is that we can evaluate expressions. So we can say print int 5 plus 5. So it'll evaluate 5 plus 5, then call print int, and then obviously this is the end of our command right here. Expression of type int. I think I have to put parentheses here. I believe that's what it's barking at me for. Yeah, it's barking at me for that. Alright, I'll explain that. And then we get 10. So the problem was I didn't surround everything in parentheses. We'll get to this in a future video about why that's important, but essentially OCaml is all about simplification. So print int just wants to print one number, print int, print integer. It doesn't want to print 2. So we first of all have to simplify 5 plus 5 before passing it to print int. So that's what we do there. We have other operations like times. So we can run this. Run OCaml 25, and we can go crazy here. We can make a little calculator, I guess, out of this, and look at that, 236435 out of this expression. I always think that's pretty cool. How it can handle big computations. We could do something crazy like this. I don't know if this is going to be out of bounds or whatever. Meaning that let's just see if this works. Oh, it actually works. Okay. It wasn't too much for the computer to handle. Some programming languages don't let you do this because the number's too big. That's like for a future video. Alright, now you might get to the point where this is getting pretty tedious of doing OCaml C-O video.ml and OCaml run. So wouldn't it be nice if we had like an automatic like program that we just type in 5 plus 5 and it'll print 10? Yeah, we actually have that, and if we go to this site called try.ocamlpro.com, it has like a nice little terminal right here where you could type in our expressions and it'll evaluate immediately. We won't be using this for future videos. As we do more complicated projects, this obviously can't handle it, but for the quick and clean stuff, we're going to use this. It's a great way to test it out, and without you having to type in OCaml C and OCaml run, it does it automatically. So I could do 5 plus 5, double semicolon, and it'll evaluate. But this is a smart program, and it knows that if I just type in 5 plus 5, it'll even add the double semicolons for us, So that's the luxury of using this program right here. And it tells us that our return type is an integer, so 5 plus 5 is 10, which is an integer. So let's get to the other operations. We have division. 5 divided by 5 is 1. 5 divided by 4 is going to be 1. We're going to get to this this little detail in OCaml in a future video, but know that you can't really divide in. Basically, if you divide integers, your result's going to be an integer, and by definition, an integer can't have any decimal values. But we'll get to that in a future video. We have subtraction, -1. We even have something called a modulus, which is basically if I do, let's say 5 mod 4, we get 1. Modulus says, okay, we take the first number and we divide it by this last number, and whatever the remainder is, that's our output. So 5 mod 4 is saying, okay, we divide 5 by 4, we get 1, and then remainder 1, and that remainder 1 gets popped off. So 99 mod 2 would be like 1. Again, we could divide up until 98, the remainder is 1. It's always pretty cool. It's pretty helpful in computer science. So with that in mind, we covered all the numbers, and again, we could do complex stuff like 777 times 43 mod I don't know, 56 times 9. Let's just see. Look at that, 147, if you never knew. So you can combine expressions like that. Just be sure to follow orders of operation. Hopefully the compiler or try OCAML will be able to understand it, but just put things in parentheses to be safe, right? So we want this to evaluate, and then do our total modulus. Now we're going to get to something called, so those are like integers, numbers. Now we're going to get to something called Booleans. Booleans are true or false values. So true, that's a Boolean, right? Type bool. Or we have false, which is also Boolean, so Boolean false. So everything is either true or false. So this following expression is a Boolean, right? We have 5 is greater than 3. So and we should put that in parentheses. I think if we leave it out, yeah, it still works out. But basically, it's saying, okay, we take the number 5, and is it greater than 3? Right? This is something that we learn in grade school math, and it'll evaluate that to true. And we could say, all right, well, it's 5 greater than 7, and that's false, and it'll tell us false. So we can do many things with this. We have equality, 1 equals 1, true, 1 equals negative 1, false. We could do greater than or equal to, 5 is greater than or equal to 5, that's true. So basically everything as a Boolean will boil down to either true or false. And we could clear this console if we're getting a little tired of it. So we're going to use those in the next video, just keep those in mind. And the last type I want to talk about are called strings, which we already know. I could type in hello. I can even leave out those double semicolons. And it says return type is string, so hello. And the cool part is I could do something called concatenate, which takes one string and adds another string to it. So it's just like merging strings. So I could say hello, the caret signs for concatenate, hello world. And our output string is going to be hello world. I can leave a space in there. That'd kind of be nice. And I can do this as many times as I want. So I could say H, concatenate I, concatenate, exclamation point, hi. Also, I want to bring up a good point. If I do the string of 5, the type is a string, because anything in these quotes is a string. Even though I typed out the number 5, it's not an integer, it's considered a string. So that's an important point to realize as we go forward with this. But those are the basics of the types in OCAML. Obviously, I'm leaving out quite a bit. We saw the example earlier where I did 5 divided by 4 is equal to 1. We still don't know what that's all about, but I gave you a hint in that I said that 2 integers, when you do an operation between them, the results in integer. So that implies that there's some other types that allow decimal values, in which they're called floating point values. We'll get to those in another video as we need them. But this is the basic types. I know it's a lot to digest, but go on, try OCAML Pro, go in Visual Studio Code, try out some stuff, see if you got the hang of it, and let me know if you have any questions in the comment section below. Thanks, guys.